phosphorus. We're going to look at phosphorus as a plant nutrient. We will start out with soil phosphorus. In the soil, phosphorus is found almost exclusively in the form of organophosphate. You can see this is a little bit more complex nutrient. You have phosphorus in the middle, you have 4 oxygens around the outside. One of the oxygen is double bound. 2 of the oxygens have hydrogens with them, and you can have 1 oxygen that has a negative charge. Therefore, this is functioning as an anion. Phosphorus concentrations usually occur in the range of 500 to 800 milligrams per kilogram dry soil, which is the equivalent of about 1,000 to 4,000 pounds per acre. This is a very large amount of material compared to some of the other elements. In many soils, a substantial amount is associated with the organic matter. This is an anion. Therefore, the organic matter tends to have a lot of charge that can hold it in place. Some of it goes back into the soil from decomposing organic matter. In mineral soils, the proportion of organic phosphorus ranges from 20 to 80%. This could be a significant amount of what you have in the soil. Despite relatively high concentrations, phosphorus has varying accessibility to plants, which means it is not always available to be picked up. Phosphate in the soil solution is completely accessible, but this makes up only a small fraction of the total phosphorus in the soil. Typically, more than 90% of phosphorus is presented as insoluble and fixed forms. An insoluble or a fixed form is going to be where it is bound onto something that makes it insoluble. This is much like many other nutrients where you have a substantial amount in the soil, but it is not necessarily available to the plant. Primary phosphate minerals are one of your major sources, as is your humus or your organic phosphorus. Then you have insoluble phosphates of calcium, iron, and aluminum. Remember, these are all di- and trivalent cations, so when they bind things, they tend to make them insoluble. Therefore, the phosphorus must be replaced off in order to have it available. You can also find phosphorus fixed by hydrous oxides and silicate materials. We've got a fairly interesting cycle here. Starting at the top are animal wastes or plant residues that have phosphorus in them. These decompose into the organic fraction in the soil. Some of the phosphorus will be solubilized into solution phosphorus, which can be phosphoric acids or one of the phosphoric acid type materials. The phosphorus in the soil solution is also affected by the application of synthetic phosphorus. All of the solution phosphorus can be taken up by the plant. It can also be lost through runoff. It can be lost through leaching. It can be exchanged into primary exchange with primary minerals. It can be precipitated into secondary minerals, or it can be attached to mineral surfaces that can be lost through erosion. Again, our primary source of phosphorus is going to be something in the soil or something in the rock that is creating the soil. In general, phosphate availability to plants can be assessed by measuring phosphorus concentrations of the soil solution and the ability of the soil to maintain the soil solution concentration. This is what is called the phosphate buffering capacity. When the buffering capacity is good, you get good plant growth. Concentrations of about 100 micromolar per cubic meter of phosphate in the soil solution are considered as high and represent a high level of available phosphate. You have to know what's in the solution and how much of it actually can get into solution. Phosphate concentrations below 1 micromolar per cubic meter in the soil solution are generally considered too low to supply crops adequately with phosphorus. There is a big range in between here. In between these two values, one is considered as high level of available phosphorus and the other as a low level of available phosphorus. Optimum soil solution phosphate conditions differ for individual crops, cropping system, and particular sites. Only a relatively small amount, less than 15% of the phosphorus fertilizer applied to the soil, is usually recovered by a crop grown immediately after application. This means you put it down and you only get a small portion of it back. This also means you leave a large portion of it for next year as well. The remainder is either leached or converted into insoluble forms in the non-liable fraction. Phosphate fertilizers. There are quite a few of them and they are quite important. You look at the concentration of what they call P2O5. We always put it down as P2O5 in the material. When you are looking at these include various forms of phosphate. The amount ranged from a low of 4% for rock phosphate to a high of 54% for diammonium phosphate. Superphosphate is made by adding sulfuric acid to rock phosphate, thus making the rock phosphate more available. Many of these minerals are not water soluble and need acid to release the phosphorus into the soil solution. Acid-soluble forms can be added to acidic soils, and this will help balance pH. Slag is a material that you get off mining, and it will have some phosphorus in it. Then you've got things like ground rock phosphate. You take the rock out and you grind it up, and you apply that. Application of phosphate is basically as a dry powder. It is applied when you are applying other materials as well. You want to apply it before planting, or possibly you might do it at the time of planting. Soluble forms can be applied through fertigation. Phosphorus, very important material. A lot of it is used. You can see extreme importance of it in the plant or in all organisms. So therefore, you must have sufficient amounts of phosphorus in the soil for the plant to be able to pick it up.